All right, so here we got the last act. In the process for manufacturing glass stems are sealed by heating them in a flame. Let X be the temperature in degrees Celsius for a randomly chosen glass. The mean and standard deviation of X are 550 degrees Celsius and 5.7 degrees Celsius. All right, so part A is the temperature a discrete or continuous random variable. Explain. Now, this is going to be a continuous random variable because you don't just have fixed numbers that are possible for X. You don't have, in other words, you don't have values that are just like 550, 551, 552, 553, 540. You have like anything between 550, 560. You can have like 551.1, 551.23, 551.72. Any two values you pick, you can always find another value that X could be between them. So it's on a continuum. So it takes on an infinite possible value and an infinite possible set of values on any interval. All right, how is the probability of X less than 540 related to the probability of X is less than or equal to 540? So let me just draw a sketch of what we're getting at here. So this is we're told that this is the normal. We're actually not, well, we're told it's we know it's continuous. It has a mean of 550 and a standard deviation 5.7. Now it doesn't actually say if it's normal, so I don't know. So you cannot technically draw that, but I want to give you a visual of what's going on. But if it's continuous, so we don't know what shape it is. Let's just say it does some weird, shape like this. Maybe it's like a rectangular distribution. Who knows? Just just go with it. This is the distribution of X. Now, let's say 540. The X is 540 is right here. 540 is here. Now, if you're trying to find the probability that X is less than 540, in a density function, just in a distribution where you have some area, that means you're not let's say you have like a dashed line at 540, you're not including 540, or you're trying to find the area to the left of 540. Hypothetically speaking, we're trying to find that area. That would be the probability. But if you're trying, let's say you're trying to find the probability then of X being less than or equal to 540. It's like, how do these compare? Well, the only real difference is that X being less than or equal to 540 is you're going to include the line. You're going to include the line plus that area. And mathematically speaking, there is no area on a line. The line has no area. It's kind of an abstract concept. It doesn't really make sense. But a line is not, it doesn't have any width, doesn't have any area. It just represents, a boundary. So they would be equal. It would be equal. We'd say equal. And that's only because of that's because they're just continuous random variables. If they were discrete, it would be a different story. All right, now part C. The target temperature is 550 degrees Celsius, where the mean standard deviation is the number of degrees off target. So let's say D is equal to X minus 550. All right, so D represents the difference of X and 550. So if we want to find the mean of D and the standard deviation of D. Now, the properties when you're dealing with sums or differences of random variables say that when you have a variable that's a difference of two random variables, then the mean difference will just be equal to the differences of the mean. So this will be equal to the mean of X minus 550, which is a constant. So 550, or the mean of X is 550, so it's just 550 minus 550, which is 0. That makes sense because, if the target temperature is 550, on average, we want it to be, it's probably going to be 550. On average, it's going to be equal to it, so there's no difference. Now, the standard deviation, now this is where you got to think carefully. This is kind of like, this is one that's kind of here to trick you. If we're talking about the standard deviation of the difference, we're talking about a number a number that describes the spread of a distribution. Now, when you change a variable by adding or subtracting some number, you're not going to change the spread. So the standard deviation is actually going to stay the same. The standard deviation is going to be 5.7 still. So let's think of this. Let's say if I have, let's draw again random distribution, random density distribution. Let's say here that has a value of 10, and this has a value over here, let's say 15. So let's say the spread, there's the difference of 10 and 15 are 5. They're 5 away. That's the range. So the range is also measure spread. Now, if I was to say, let's say, if I was to take away, let's say 5, or 550 from these values, let's just say 5 to make the numbers easier. If I took 5 away from 10, that would be 5. And then 5 away from 15, that would be 10. Now the main difference, the standard deviation, or in this case, the difference or the range between 5 and 10 is the same. I'm just doing this for a hypothetical example to make it easy to understand. But again, if we were just to change the endpoints of this distribution by subtracting 5, the values themselves change, but the spread doesn't change. They're still just 5 apart. So think of the standard deviation as a measure of spread. So what it does, it's not going to change when you just add or subtract a number, because you're adding and subtracting that same number to all the values. I could maybe increase these by 10. That becomes a 20. That becomes a 25. There's still 20 to 25 is still 5 away. That's just some kind of intuition for why that is. All right, and then part D, the manager asks for the results in degrees Fahrenheit. The conversion of x into degrees Fahrenheit is given by y being equal to 9/5 x plus 32. What does it mean of y? What does it mean of y? And the standard deviation of y. Using this. Okay, so this is, we're going to kind of touch back on these properties when you multiply, and when you multiply and add, by a scalar to a random variable, you apply if you remember in chapter 2, talking about linear transformations. So here we're doing a linear transformation, mathematically speaking. So when you do a linear transformation, let me write it like changing x to y. It's kind of just an overview of the notes or how I explain this. When you change x to y with the linear transformation, what you're doing is, y is going to be, capitalized. You're basically multiplying a by some scalar and adding some value. So like it's usually in statistics, it's usually like ax plus b. So it's like ax, a times x plus b. That's what you're doing to get y. Now the mean here is, going to be 9/5 times the mean of x. 9/5 times the mean of x plus 32. For means, you're going to multiply and add those same values. Correspondingly. That's a word, that makes sense. So it'll be 9/5 times 550 plus 32. You'll get it to like 1,022. To 1,022. So the mean of y would be 1,022. And 1,032 degrees Fahrenheit. Now in the standard deviation, for spread, remember the mean. Remember we kind of went over this concept in C. For standard deviation, you don't care about what you add. The standard deviation is not affected by values you add or subtract, but it is affected by multiplication. So the standard deviation of y will be 9/5 times the standard deviation of x. So it'll be 9/5 times 5.7. You'll get I typed it wrong. 9.7 times 5.7. Oops. You get 1.8 times 5.7, and that'll be about 10.26, or not about 10.26. 10.26 degrees Fahrenheit. And that's all there is to it.